Hey, how's it going, Johnny?
Hey, Joe. Good to see you.
Yeah, good to see you too. Yeah, so I think we're gonna have a fun technical deep dive into logs, streaming, and that fun universe there. So looking forward to it. For people who don't know who you are, do you want to give a quick intro?
Yeah, sure. So my name is Johnny. I'm Johnny Graettinger. I'm the co-founder of Estuary. We are a data orchestration, data infrastructure tool for basically keeping your systems in sync and talking to each other and revolving around the same data sets. And I've spent a bunch of time sort of in the streaming space, both through this company and also previous companies. I'm kind of recovering from the advertising technology
Mm,
industry where I spent a whole bunch of years, which, whatever you may think as an engineer, it does have some really interesting data
mhm.
challenges and where speed is really of the essence. So it's kind of a neat space to explore some of these techniques and think about these problems.
Walk me through some of those technical challenges. I think this is going to play into some of our uh, upcoming discussion points. But what makes advertising and ad tech unique, and what are some of the engineering challenges that you see there?
Yeah, it's two things. I mean, it's both the volume of data, and it's also the speed with which you really need to kind of move and process data. So, just in terms of volumes, I spent some time working on a company that became what is now Google's DoubleClick Bid Manager,
Mm.
and there you're dealing with is in a space called programmatic advertising, which basically means like APIs for buying and selling advertisements online. And you are typically working with like trying to make decisions about whether or not you want to buy a particular advertisement opportunity, and you have to make that decision in about 100 milliseconds, maybe 150 milliseconds, and you're doing that about a million times per second. So you need a, it's very fast. You have to make decisions very quickly. And there's a lot of data involved in this process, of course, too, because if you're trying to make a buy or sell decision, like you need data in order to inform that decision. So the data's got to be there in the shapes that you want it, and to query it in order to make that decision. And then once you've actually bought an advertisement, for example, there's more data that gets thrown off. So you have what are called like impressions when someone actually sees an advertisement, and that's basically a data record about an event that happened, that impression happened. And then there's all kinds of other sort of data events that are used somewhere in the process of making a decision about buying or selling an ad. So you're generally dealing with an influx of data that's in the hundreds of thousands to millions of queries per second, where each of these are individual events that are telling you something important that you don't want to forget, and you might also want to kind of like stitch that information that you're getting into an understanding that you are then using to make a purchase decision or like a ad buying decision, a second later or very shortly thereafter. So you basically need to kind of like keep these indices that you're using up to date quickly so that you can use the most recent information in order to make a decision.
Sounds really complicated. So let's dive into this. When you're dealing with millions of events per second, large volumes of data, like do you at the time that you were working in this, was it possible to just buy products off the shelf, or did you have to build your own tooling to handle this?
Yeah. So before Estuary, we were building a company called Arbor that was in sort of the advertising space and the advertising data space. And we were figuring out what that company was going to be. And one of the sort of primary challenges of the model for the company was that we did better the faster we were able to sort of take all these disparate data points and integrate them together and build up sort of an index, a representational data model that we could query quickly to make a decision. So it was really fundamental for in terms of how that business made revenue, that we'd be able to do that really quickly. So at the time, and this is back in like 2014, the incumbent for doing something like this was, of course, Kafka. So Kafka is something that I certainly considered at the time. We ended up going our own path and
Mm.
implemented a system that we've now open sourced called Gazette. And the central reason for doing that, for not using Kafka at that time and continuing, building Gazette and continuing to evolve it over the years, the primary advantage that Gazette gives is being able to essentially work with immutable logs in a cloud scaled way. So basically using native cloud storage S3 really efficiently for sort of managing the content of a append only log that's built up over time. And one of the really key things that lets us do, and lets us we continue to be able to do, is isolating, like separating the writing of data from the management of that data in the log and the material, like the replay of that data. So one of the key things it enables is being able to stand up a new downstream task that basically is going to like work with a big data set, and it's going to backfill over potentially weeks, months, years of history, and do that with as much throughput as possible in a maximally efficient way, where it's basically just soaking up all the IO bandwidth that S3 can offer, and have that be able to seamlessly switch over to sort of millisecond latency streaming, and be able to do all of that without putting the ongoing production rights at risk. So basically, the system that is accepting new writes that are coming in, that cannot be impacted by sort of a large scale materialization that might be replaying all this history and catching up to the present. So I had a person put it well to me. It basically it gives us freedom to be fearless in terms of standing up sort of new tasks, new consumers of data, sort of making our overall data flow more complicated without causing undue risk on production systems that really can't go down.
Is that because you're relying on the object storage?
That's right. Yeah. Yeah. Because the actual peeling back a layer on architecture, what Gazette is doing is it's managing sort of the incoming writes and getting those down, getting them replicated, making sure they're not lost. But then it gets them into cloud storage pretty much as quickly as it reasonably can. And thereafter, if you're reading that historical data, all the brokers are really doing is just handing out like URLs, signed URLs to go read the next gigabyte of data or so. So that ends up being like really cheap. Consumers are just periodically asking like, hey, where do I go get the next gigabyte of data? And brokers hand back like a URL to go read the data. And that's essentially it. So it's a very lightweight in terms of resource usage.
Yeah,
It's a very lightweight imposition on the brokers.
Yeah, it seems like you need to know the kind of the innards of S3 in order to make that work, because it's definitely possible to hotspot yourself, for example, if you don't know how to partition your buckets correctly, especially back in the day when I think they've changed quite a bit since then. But I know back in probably when you were doing this, it wasn't always the case. Like S3 was it's a bit more raw at the time. So.
Yeah, they've definitely improved, and we really don't see it as a problem these days.
Yeah.
And all of the clouds, whether it's Azure or S3 or Google Cloud Storage, they all have pretty much the same fundamental API of like store a blob of data. You can get a signed URL, which is a pretty neat thing. Like a signed URL basically gives the bearer of that URL a capability to go read the object for a time limited period. So it really kind of simplifies like authorization. If you have distributed sort of processors of data, you can kind of wrap it up in that bearer token scheme.
Walk me through this, because I mean you're dealing with an ad tech system and you're using S3, but especially at the time, and I don't think it's gotten any better, but a cross-region replication and accessing S3 between different. What I'm trying to get at is basically the egress costs that might be associated with transferring data. How did you manage that kind of stuff?
Yeah, I mean, generally don't.
Just pay the piper.
Yeah, if you can leave the data in a region, in a specific region, and have it be kind of homed in that region, and then move your processing to be in that same region, that tends to be the best way at it. So, we tried not to really move data much cross region. You do it one time and then sort of have one place where it's centralized. This picture has, of course, gotten way more complicated with GDPR and all that. Where it's now like there are lots of great reasons why you might have different data sets stored in different regions, and they really can't travel between those regions. So the picture has only gotten more complicated. But generally these pricing models are set up where reads within a region are very cheap,
Mhm.
like super cheap, and they work pretty well in terms of like different availability zones within a region. Like you're not paying more for there isn't like a cross availability zone network cost as there would be if you were doing direct AZ to AZ transfer.
Yeah.
So it ends up being like the pricing economics are a little bit better because of that. But yeah, if you're moving data from the East Coast to the West Coast, try not to, or like compute kind of an aggregation or a roll up of
Yeah.
your first.
That's interesting. So, what did you? Does Gazette have its own file system, or were you just storing the raw objects in S3?
Yeah. So Gazette, basically, it's modeling a byte stream. So you can build
Okay.
all kinds of different formats on top of it. Some common ones are like delimited protobuf or CSV or JSON or what have you. So it's kind of on you as the user to come up with your own framing for how individual messages or records are going to be represented. But the core concept within Gazette is the journal, and it's literally a byte stream. And when data gets persisted to cloud storage, it is just the raw byte stream content of your journal. So if you're using like line delimited JSON, for example, you get a bunch of objects, cloud storage objects, files that are line delimited JSON. And it's basically using an encoding within the names of objects to figure out how they all stitch together into the
Mm.
overall log. Basically, like a file listing becomes an index for how to read data.
File listing comes in. Okay, that makes a lot of
Yeah.
sense. Yeah.
And just to unpack that one more level, just to
Yeah.
make sure it's crystal clear, you can encode sort of the offsets of where a particular file sits within the overall, log stream. You can encode those offsets in the name of the file, such that they order where like a sorted listing of the files becomes sort of a sorted index over different files and their coverage of different offsets within the log.
Interesting. How would you handle things like late arriving data? Does that just go into does it go back to a preceding offset, or does it just get dumped into wherever it landed?
Yeah. So late arriving data it depends a little bit on like what layer of the stack you're at in terms of
Okay.
defining like whether something is late arriving or not. So this is a nuanced answer, and I'm trying to like unpack it
No,
for like
unpack it to your heart's
yeah,
content.
at the lowest level within the broker, which is again just dealing with byte streams. It's dealing with like different. So the broker, which is managing a particular journal, which is again this infinite byte stream. It is accepting, it's got a few competing rights that are coming from different clients, where these different clients are saying like, hey, I want to append this chunk of bytes to this journal. And the broker's role is to figure out like what is the order that those bytes are going to land in. And it's just going to pick one. It's just going to pick some order that the bytes are going to land in. So at that level, there's no such thing as late arriving data because data is always just appended to the
Right.
journal. When you go up a little bit higher, then like higher in the stack, there can be such a thing as late arriving data. So at this point, you've got some notion of like a message or a record that's being represented within your event stream. And those records can have timestamps. It depends a little bit on where the timestamp's coming from. If this is, coming from some upstream server process that stamped it with a timestamp, and then there was a delay in terms of like the actual writing of that data, then yeah, you can get stuff that's out of order. And trying to think where to take the rest of this answer, but because sorry, the meta conversation right now, this is at a fairly low level within the like just in terms of how brokers work, and your question is really getting at like the much higher level concern of I have a report that I'm building based on data that could be late arriving, and how does that late arriving data get folded into my report? Okay.
Or a model that needs some sort of a sequence, like a machine learning model or something like
Yeah.
that. Yeah.
So okay, the reason why that just like farted in my brain is we're really jumping from dramatically different levels of the stack
Yeah.
because
Yeah.
being a Gazette concern to like being a flow concern.
Yeah.
where I
Okay.
have like the flow answer, but so far this has been a discussion about Gazette.
Oh, sorry to jar you.
Yeah, and Gazette itself. All right, so
Yeah.
that's going to be my answer. Okay,
Okay. Okay. Perfect. Easy. There
coming
you
back in.
go. No
So
worries.
at the lowest level, there is no such thing as like late arriving data for Gazette because
Right.
everything's append only. So the order of arrival of data is wherever it kind of landed in the log.
Yeah. And that's the immutable
But
log we're talking about, right? But then it's when you process it, it's going to have whatever other concerns you have at that point, right? So,
yeah,
what were you doing for data processing back in the day? And I want to know about what you're doing, what you did for data processing then, and maybe how your approach has evolved to today on immutable logs.
yeah. So back then, and this is still kind of true today, but back then, there's this consumers framework that is part of Gazette as well, which is what we wrote streaming applications to. So the consumers framework basically gives you a way of like writing applications that receive an event and do something with it, and maybe spit out some more events, into different journals or logs because of that, and maybe update some kind of interstate, if they're keeping a counter of things or something more complicated. And we sort of built applications that were written to this framework and deployed them and ran them to sort of manage the movement and processing of data. And we're still kind of doing that. So, right now, Estuary Flow builds on top of Gazette, but it's an implementation detail of how Flow works. So Flow, the core concepts are a capture, which is capturing data from some data source, like a database or a SaaS API, a derivation, which is a transformation of some collections of data to build a new collection of data through some kind of applied transformation in various languages. And then a materialization, which is taking a collection of data and pushing it and keeping it up to date in some endpoint, like typically a warehouse or a database. So essentially we are built on top of the Gazette consumer framework, which is the same
Okay.
thing that we were using for building streaming applications back in the day. But now it's much more of sort of an implementation detail.
Mm.
And all of the captures and derivations and materializations are all sort of forms of applications written to this framework. And one thing I wanted to get at in terms of the late arriving data question,
Mhm.
that's a hard question that we've only been able to answer now. It's sort of the much higher
Oh,
level of the
interesting.
stack that we play in that with the current company and Estuary Flow. And there, the answer is that if you have late arriving data, rather than discarding it or throwing it out as some systems do or anything like that, we're basically just able to kind of flow it into the materialization or the data product that you're building. So if you have additional late arriving data that, for something that happened yesterday, for example,
Yeah.
um, rather than throwing it out, you should be able to kind of flow that through into a fact table that you're building out
Yeah.
where you've got it keyed by date, and we're going to update yesterday's outcome based on this new information from this late arriving data.
It's an interesting kind of segue into data modeling, which you mentioned earlier, right? Because I think that when you model data for events, this is one of the areas where it gets a bit. I think people maybe don't understand the nuances of late arriving data, for example, because there's a for the audience, there's the actual event time, like when an event occurred. Then there's the time that you captured the event somehow in your system, right? And these are not always the same thing. In fact, they're often not the same things at all, right? And so, as you point out, the data when it arrives, it goes typically into an immutable log. But there's also but you don't necessarily care about that in your analytics. You want to know about when the event actually happened, not when you captured it in your system. So this is
Yeah.
the nuance. But there's a lot of trickery to this kind of stuff. There's volumes of literature you can go read on windowing and all this other stuff, which I think
And there's
that's
yet
fun.
another definition of time, which is
Yes.
meaningful. That is like, I can have a time that's represented in my actual record, and that time might be yesterday, even though I'm actually writing the record today. But I still
Yeah.
care about that time, and I might
Yeah.
want that reflected in my report too.
Mm, good point.
So, yeah, there are all kinds of definitions here, and I would add that one to the pile in terms of being a really important sort of
Yeah.
definition of the meaningful time. of an event.
It's funny you mentioned this. I'm actually writing about this right now in my book on data modeling I've been working on for a while. But it's yeah, there's just different types of time and how do you think about time. It's a on the surface, I think we all take it for granted. It's like, oh, time, like have a
Yeah.
watch, it's fine. But yeah, as you point out, that yeah, there's a data that you actually want to have the date as of yesterday, for example, and I've seen kind of similar workflows where it's just yeah, it's like what do you want to ultimately what's your goal with it with the data, right? And so that's but it does require a lot of thinking, and it's one of these things where I think people just take it for granted, like oh, I just throw it into a database and it just does stuff, and I'm like right, but anyway, it's a bit of a tangent.
Mhm.
But there's a lot, and then there's nerding on tritemporality. So it's like when things happened, when you got the data, and then also like when you make the decision on it. So
Mhm.
it's like just I don't know, it's real fun. So, but I mean, so when we talk about streaming, I mean, before we started the show, you're talking about basically how you wanted to take the approach that, similar to what Postgres is taking. Maybe you want to
Yeah.
unpack what you're talking about there.
Yeah. So I find immutable logs, and I'll just use like log as a shorthand in this
Yeah.
conversation. I find them pretty fascinating because they really end up being everywhere you look, even though you might not immediately see it or recognize it. Pretty much every database out there uses a write-ahead log, which is a immutable log.
Yep.
They also come up in all kinds of other use cases like auditing, and one that pops to mind is certificate transparency, which is part of like internet security, is based on an immutable log API that basically your
Mm.
browser uses to check whether like a site might be, you know, illegitimate or malware or something. So
Interesting.
they just come up all over the place.
Accounting
Yeah,
might be
absolutely.
the first immutable log actually with double entry books. Yeah.
So, and I think it's really interesting if you peel back like the architecture of Postgres. And I think this is rather general about databases, but I'll talk about Postgres just because I happen to know more about it and won't sound like as much of an idiot. But Postgres' architecture, like we think of it as a database. And when we think of Postgres, we're interacting with tables and we're interacting with indices and that kind of thing. But I'll start with this premise, which is, the beating heart of Postgres and like kind of the central nervous system of Postgres is in figuring out what events are going to be sequenced into a write ahead log
Mhm.
and which are allowed, like which events are allowed, and basically building that write ahead log. That is the heavy lifting of the database. And the rest of what we interact with, tables and indices and whatnot, they are really kind of a materialization of that write ahead log. And looking at this like one level deeper, when you actually look at what Postgres is doing on a machine, on a piece of hardware, you've got like a multi-core server that you're using to serve Postgres. When you initiate a connection to that database, what it's doing is it's accepting your connection and forking off a new Postgres process to serve everything that you're doing over that connection. So this is basically like a parallel decoupled process that is serving your connection, and it's doing all the heavy lifting of like evaluating selects and evaluating updates. But what it's really doing when you look at it is it's kind of taking everything you're asking it to do and it's figuring out a set of proposed changes to the write ahead log. And then there's one central kind of point of coordination where it's trying to quickly make a decision based, can this write proceed? Can I make
Mhm.
this change to the write ahead log or not? And then once that decision has been made, the rest of it in terms of like maintaining indices and maintaining like table heaps and that kind of thing, it all falls out of what's in the write ahead log. So like there's this interpretation I find really fascinating where like the write ahead log is the thing and the rest of it is sort of services to help manage like what's happening within that write ahead log and then how to materialize views over what the write ahead log implies. So in some respects, like really what we're doing with Estuary is we also have an immutable log sort of as the beating heart of everything we do. And in a lot of respects, we're kind of just taking that Postgres architecture and scaling it up to the cloud.
Mhm.
That's a lot of how I think about it, at least, that basically we're, that write ahead log, that immutable log is sort of the central joint through which all of this decoupled, distributed, parallel data processing is communicating.
Right. Yeah, and what was it? The Jay Krebs article back in the day about the log. Maybe it was just called the log. I can't remember what it was,
Yeah,
but
that was a great one.
yeah, it was a great one for
There's
sure.
another one I love from Martin Kleppman, turning the database inside out with Apache Samza
Mm,
is the name of that piece, and it's always like that was an important like blog post in sort of my own
hmm.
journey
Remember that
in terms
one?
of framing all of this stuff, and so I'm actually parroting him, but just the architecture of like thinking of the log as the central thing, and then
Hmm.
thinking of everything else as kind of pipes that are hooked into this, and basically taking like the Unix philosophy of pipes and logs and scaling that up to the cloud. I think we're all, basically just still trying to execute on that vision.
Yeah, it is interesting, and I know that Jay Krebs had his Kappa architecture way back in the day that I know he was pushing for it. I'm not sure why it never happened. I actually have some pretty good ideas why it never happened. But it's it was actually really it's a great idea in principle. I think executing on it and like running that sort of an infrastructure, it's a bit more difficult than people thought. But it seems like that I was reading the other day, maybe it was not the other day, but the other week on LinkedIn, somebody was saying that was it Kafka's basically an ACID compliant database, and we should just use it as a ACID compliant database. And so I think that, as you point out, the mental leap basically is what I'm getting at is from like Postgres being a immutable log to architectures like what you've built and more quote streaming architectures. These aren't that divergent from each other if you look at it
Mhm.
from a log. And I never really thought of it in this respect, but you're absolutely correct. It's you're talking about basically at that point pretty strong different implementation details, but the underlying mechanisms are all there.
Yeah,
So
yeah, absolutely. There's, the devil is of course always in the details, but
yes they are.
it's a wonderfully freeing architecture, just in terms of if you have that log and you trust it, then you can have all kinds of different processes that are reading and writing the log and scaled independently, and all the things that make the Unix philosophy kind of nice to work with in the
Mm,
first place kind of do translate and scale to the cloud. There's one other really valuable thing that logs offer, which is basically like there is no one representation we necessarily want from a log. Like if you have a change log of events that are being made to some conceptual data set, there are a lot of questions that you can ask of that change log that have different sort of outcomes and answers. So just to ground it out a little bit specifically, like imagine that you've got a change data capture that you're doing from a source database. Now, in Estuary with Estuary Flow, that's producing an immutable log, but like essentially any kind of CDC, if you're using Debezium, that's also producing log events in essence. And you can introspect that log and you can ask it a few things. You can ask it first, hey, I want a materialization that's basically just going to mirror the content of this table in some other system. Like I want it in Snowflake or another Postgres database or whatever. And I want a materialization of this log that's just going to produce a table that looks like the source table. And it's just going to keep up to date with that source table. And that's one really valid use case.
hmm.
But another valid use case is I actually care about the changes that are happening. Like I have an audit use case and I care about the changes that are happening to this table over time. So I don't want just the current content of the table. I need to understand how it's changed over time as well so that I have a record of this. And there's yet a third use case, which is point in time, like recovery.
Mm,
So being able to essentially say, today is today, but I actually want to see what this table looked like, last Thursday at 7 p.m. And I want to reconstruct the state of this table at that particular time point. And that's another thing that you can do from that same log. So there are all these different use cases, all possible, you can serve all of them from the same log without needing to go back to that source database. So that's a really interesting aspect of it as well to me.
hmm. You mentioned change data capture. I think for the purpose of the audience's education, can you describe the difference between event streaming and change data capture?
Yeah. So change data capture uses event streaming generally. So change data capture is it's essentially the practice of capturing changes that are being made in a source system as they are happening and turning those changes into an event that then can transit through an event streaming architecture. So change data capture is essentially being able to hook into like Postgres, for example, and say, anytime I update a table or insert a new row or whatever, I want to get out events that tell me exactly which rows were changed, when they changed, how they changed, etc. And it's essentially sort of a slightly easier representation of the underlying write-ahead log that is capturing those changes as well. It's in essence, it's a translation of the write-ahead log with some important details, but
Right.
it's a translation of the write-ahead log to make it more generally useful for other downstream use cases.
Yeah. And I think it's so we're talking about databases. We're talking about getting databases, getting data out of databases for analytical purposes. For the longest time, we've been living in a batch-oriented world, but from where I sit, it seems like we're undergoing a transition. There's sort of a phase change occurring right now. It seems like, much as the modern data stack back, over 10 years ago now, started democratizing things like data warehousing and ETL processing and ELT and so forth. That's largely been simplified, I think, the batch processing. And now it feels like the same simplification and I would say democratization of event streams and so forth is becoming widely available to people. Am I off base in this observation at all, or do you feel like maybe in the next I don't know few years, some arbitrary number, say 3 to 5, streaming and events for analytical purposes will be as simple as the modern data stack has made batch analytics?
That's my hope. I mean, that's certainly kind of the world that we're building to, and I know a number of others are building to as well. Essentially, getting to the point where Kafka, we owe a debt of gratitude to Kafka in many ways, but no one has ever called it sort of easy to operate,
Right.
or it's not a piece of infrastructure you bring to bear without an engineering team that is going to be caring for it and feeding it and that sort of thing over time. And I believe in that we can essentially build like the fundamental capability set that kind of heavyweight infrastructure brings you, that we can build products and essentially manage services and just much easier to use tooling that captures all of that same benefit and value and is using the same sort of efficient optimizations under the hood. Like the actual a core thing that Kafka brings is just only moving incremental changes. Like,
Mm-hmm.
when we talk about sort of the modern data stack, a common issue with the modern data stack is you end up copying big piles of data over and over again
Yeah.
between different sources and destinations. And one of the first benefits you get when you bring in like Kafka plus Debezium is at least now you're only moving incremental changes rather than wholesale copies of tables and that sort of thing.
Yeah.
So, but as an industry, there's still definitely like things could be easier. I don't think we're quite at the point where it's, the goal line to me is the same. Like I as a user don't really need to care too much about the details or that even
Mm-hmm.
that it's using event streaming under the hood. Like event streaming
Right.
is an implementation detail.
Yep.
It doesn't matter to me as a user. It doesn't matter to the outcome I want, which is sort of my data to be in these different places and just always up to date, and for that to be done cheaply, and to be able to sort of like declaratively describe change or transformations to that data that I want to be done and just have them be done for me,
Mm-hmm.
and sort of have a much more sort of outcome driven model for how I work with the tool rather than needing to think about like writing applications to do this
Mm-hmm.
transformation for me.
Why do you think it's taken so long to get here?
Yeah, I think in some respects, what makes this particularly hard is the batch world and the modern data stack world have a lot of like really simplifying assumptions that make those implementations sort of embarrassingly parallel and a little bit easier to
Mm-hmm.
implement. I'll give one specific example. When you have a query that you issue to Snowflake, the life cycle of that query is, seconds to minutes, maybe hours, and then it's done. Like the query's gone, it's thrown away, that's it. And in terms of the data it's going to process like the content of your table as it exists at that time, and that's it. If you compare that to then saying like, all right, I want this same query, the same transformation, but I want this to be a streaming transformation that happens all the time. So now the life cycle of that query is dramatically different, because now this query is essentially something that's going to be running for weeks or months or even years. And the amount of data it's going to process is quite a bit different as well. So basically, like the fundamentals of the query and its lifetime and what it's doing, they change pretty dramatically. And one other thing is that, like, if you're doing a join, for example, and you're doing that join within Snowflake, Snowflake is basically computing sort of a hash table under the hood, where it's basically sort of doing a parallel hashing and mapping of the content of the tables that are being joined. And then it throws that away when it's done. So that hash join product is basically something it's ephemeral. It can build it on demand.
Mm-hmm.
When you translate that same thing to a streaming use case, that hash table suddenly, now this needs to be like a long living deployed application. Yep. It needs to be fault tolerant. You need to be able to recover on failure. You might need to be able to scale it out because you realize it's not quite big enough and you need to add more parallelism. So there are a lot of like legitimate complexities in terms of taking this model and adapting it to a sort of a continuous streaming world.
Oh yeah, I remember I was talking with Gian Merlino a few years ago when he was he's the guy who helped create Druid, and we're just when we were doing, I think we were riding in my car to a meetup, and I was asking him, so because it's about the time that they're working on joins for Druid, which in the past was just they didn't do joins for very obvious reasons because it's performance killing, and but the amount of mental gymnastics at that time to figure out how to do joins that weren't going to completely make performance suck for everybody was a lot. I mean, we're talking a lot of brain power going into this, and it was a very, very difficult thing to do. So it was, I mean, you're going back to like basically fundamental stuff like bitmap hashing and stuff like that to like atomically figure out how you're going to make this work. So yeah, to your point, it's hard.
And even getting away from like the technical implementation complexity for a moment, I think there's kind of like a model, like we're still figuring out the right model. So going back to the example of a SQL query, SQL queries, they're kind of like one shot. You submit a query, it runs, you cancel it if you don't care anymore, you get results otherwise. And that, like, you can take that model and you can lift it into the streaming world and essentially say, I'm going to submit a query. It's going to process all my data. It's going to give me new incremental streaming results. And that's a really cool capability. I'm not dismissing it in any way, but at the same time, it's still kind of a one-shot model where like you submit the query, it runs, you cancel it when you don't care anymore. And that's not really reflective of what we need it to do in the real world, because again, this query is an application that's deployed for months, years, even. Like, it's going to change over time. The requirements are going to change. We're going to want it to do other things. There might be bugs we need to fix. And if, again, because this query can potentially be running for very long periods of time, it can have processed enormous amounts of data along the way. So we don't necessarily want it to have to reprocess all of that every time we're making a change or adding a new feature to it or fixing something. So I don't know that queries are the right model, just because of that. Like, you need to have just from a software development practice point of view, you need to have a way of evolving that query over time to address like new features or a slightly different way that you want to do the join or additional columns, what have you. So they really need to be more mutable than they really are in the industry right now.
How should one think about their data as well? Because I think this is maybe the other component. In SQL, there's a certain way that you would structure data, say, in a transactional database, data warehouse, and so forth. But when it comes to streaming, it feels like this is sort of no man's land. Like, it's how do you structure events in such a way that they give you the information that's needed either by a human or a machine, but is also performant when you're running it through whatever streaming transformation or processing you're doing?
Yeah. It is a good question, and it's also like often when people talk about the data or data ecosystem tools or representations, people often go first to like databases, and they're thinking
Hmm.
of it in terms of tables and like
Right.
how do I represent this for tables? But there's actually a much wider world of like data sources that people have and care about. So that can be things like MongoDB installations, there's DynamoDB, or APIs as well. If you're grabbing a whole bunch of API responses from some SaaS vendor you work with, so there's all kinds of different representations for you can have different extremes of like very normalized data in like a star schema database, and you can also have very denormalized data where you're getting sort of like a customer record that embeds like a list of addresses and sort of embeds all this richer metadata about the customer in a structured way. Our answer is honestly JSON, or at least the JSON object model, enriched with additional things that come from JSON schema. So adding types like UIDs and date times and all that stuff. So adding like the really common formats that everybody wants and needs, but that's still fundamentally representable as JSON. I've not really found anything better,
Hmm.
particularly for like another core thing about streaming is that it is sort of row oriented in nature. So, we have a lot of really interesting work that's happening for columnar formats, where you're essentially sort of inverting the representation and you're representing like all the values of a column together for a batch of rows. And that's also a valuable representation, but it's not, there's a bit of an impedance mismatch if you're trying to use that representation for an event streaming use case where you might need to like map and filter rows a row at a time.
It's really interesting. And I don't know, how do you think about modeling your event then? Do you tend to go kind of like really fat event where you contain all your information, or are you trying to keep your events as discrete as possible?
Yeah. Um, the There is no one size fits all, and like one of the really common needs is to basically take sort of a thicker event that embeds or inlines a whole bunch of sort of sub events and kind of map it out into more normalized discrete events. So you really, my opinion, my answer tends to be favor somewhat fatter events that represent sort of the core domain entities of your space, whatever that is. If you have a customer, then your change events can be about customers, and you probably don't need or want like, you know, of course the answer is it depends, but you may not want like individual records that are representing changes to like the event streamed like customer address, like house number, for example. That would not be a useful event.
Right.
You would probably want that to be more oriented at like the entire customer record, presuming that that's not a very large thing. So, sorry, I know this is a bit of a rambly answer, and it is a it depends answer. But with events, I certainly think that Fivetran has taken things too far in terms of the like
Mm.
hyper normalized representations, and the happy medium is much more on sort of like the somewhat thicker events that inline sort of sub events that are have a reasonably bounded size, and then kind of map those into more normalized representations if that's what you're after.
Right. And so I'm guessing you'd probably advise having some sort of ID. So if you wanted to join these different events together later down the road, you can, right? Or
Yeah,
yeah,
certainly. And there almost always is some like domain specific ID already
yeah,
that exists.
hmm, yeah. It's interesting. What are your thoughts on the current data integration provider space? It's you mentioned one company, Fivetran, for full disclosure, ternary data. We have worked with them in the past. We're not doing as much consulting anymore, but there's sort of the I would say the kings of the hill, so to speak, right now with respect to the to the modern data stack integration tooling providers. But it seems like as a Big Data London recently, and there were a ton of data integration providers. I think I could just throw a pile of gravel, and probably every single stone would hit a data integration provider. There were so many. And what's it like in the space right now? Trying to create a startup that in what seems to be very crowded space.
Yeah, it certainly is a crowded space, and I'll caveat this with I'm probably not the best person to ask, just because I'm really not paying that much attention, if I'm being honest.
Oh
Like
yeah, no
I'm,
worries. Well, it's probably a good
um,
sign actually. You're just focused on
yeah,
building
I
good product.
pretty much all of my attention is on sort of like, yeah, it's our own sort of product development and R&D and that kind of thing. So
Hmm.
I'm really not super steeped in kind of other
Hmm.
companies that are out there and what they're doing and that sort of thing. But it is certainly it's a crowded and confusing space right now,
Hmm.
and it's really hard to tell as a potential customer or consumer within the space. It's really hard to differentiate what different tools do and how they function, and some of the like a lot of tools will say the same thing on the tin, but it's kind of hard to understand what that actually means in terms of what's happening beneath the surface and what the implications are for you and your usage of the tool. So it's a little crowded, certainly. We'll see what happens over the next few years. I think part of that is reflective of how much it's still up in the air.
Hmm.
At the same time, I mean, there's like clearly there need to be better solutions for low latency, like data synchronization and movement and transformation and all of that. But the how of where we get there is still so much up in the air, and I think that's reflective in terms of the number of aspiring companies in the
Mm.
space.
Yeah, and I mean, in my world, I would think that I would prefer everything just be live and quote real time. I don't see a reason why I would want to wait on stuff. But it really feels like the end use cases, so BI tools, I don't feel I've caught up to the the quote real time analytical use cases as much as they should, right? I mean, everyone's so when you're talking about the end users of these products, it feels like the selection of options is still very much stuck in a batch oriented world. For example, even the analytical data stores, it's still, even if they say they do real time analytics, I know under the hood that they don't quite do exactly real time analytics. You might be waiting a while for certain things. So it feels like, the upstream stuff like the event streaming is I think it feels like that's getting simplified, but it just feels like as you sort of move down, like I said, to the end user, it's still stuck in a sort of a time machine like 5 years ago. So I think that might be one of the things that needs to change, is what I'm saying, because it's otherwise you're
Yeah,
going to make it. It's going to change when the demand for this sort of stuff improves, but it only improves when the downstream users have the capability of doing it.
yeah,
So
certainly. And I think the customer journey it often starts with like, first I just want my data in the warehouse, in
yeah,
an analytics warehouse, and that is a completely reasonable thing to want. Everyone, pretty much everyone knows how to write SQL. There are often lots of analysts within the company who know how to do it. So that that is goal number one. It's got to be in the analytics warehouse where you can sort of poke at it. But the next step is like, I think of it in terms of, the analytics warehouse is great for figuring out the right question.
hmm,
It's for playing with the data and figuring out what the questions that you want to ask are. But once you've figured out what the question is, that it becomes an opportunity to look at how you can optimize answering that question over and over and over again.
for
Because
sure,
generally, analytics warehouses are not the most efficient way to do that. They're certainly easy, but once you've identified the question, you can generally, lift it into an implementation that can operate more continuously and give you sort of more real-time results.
for sure. And the other ways to do it is just work in a data intensive job like you did back in the day. Then you're kind of
Yeah.
like thrown into the deep end, and you have to do this.
Yeah.
It's like there's no option. So
Yep. Exactly. And I think the industry will start to shift when it
yeah.
becomes so easy to, lift
Hmm.
those kinds of queries, basically the outcomes you want in terms of the view or the data product, and lift that into, you know, I can, instead of having to run this query in my Snowflake warehouse, I can run it continuously and just have it update in a Google Sheet. And then that's
That'd be
what my
sick.
business user is using. And they've just got like a Google spreadsheet with an always up to date answer. Um, so I think this will change over time. It's certainly true that like the table stakes today is still like first get it in the warehouse and
Hmm.
then kind of show value with how you can transform this and put it in other places as well.
Yeah, it's crazy. It's crazy. We're still in that land. I mean, this weekend I'm going to go off and hang out with Bill Inman, who came up with a data warehouse. But it's like even he forgot about it. He's like, "Oh, I came up with that," but it was like it was a while ago, right? So he's moved on. But it's crazy that we're still, I think, um, that's sort of the table stakes at this point, right? So, but it is what it is. So,
Mhm.
yeah. Well, awesome, man. Yeah, good chat. Learned a lot. And for people who want to learn more about you, Gazette, Estuary, how can they do all that?
Yeah. Our website is estuary, estuary .dev. You can also find us on GitHub. And if you're interested in Gazette, so Gazette is a Estuary Flow is source available. It's business source license, which basically gives you rights to run it in house for your own use case. We'd like to make this a little bit easier over time. Full disclosure, it's currently not super easy to set up yourself.
Hmm.
Um, and then Gazette is MIT licensed, and that's kind of a implementation detail, as I noted, but that is sort of a Go implement, like it's a uh, broker and consumer framework architecture written in Go. That
Nice.
is the basis of what we build on at Estuary as well.
It's cool.
And that is, I was double check myself before. So Gazette, Gazette,
Okay.
as in like, the Daily Gazette .dev.
Cool. Sounds good. I'll put all the links in the show notes. Well, Johnny, thanks for the fun chat. And
Yeah, thanks for having me.
yeah,
It's always
anytime.
fun.
Yeah, likewise. Take care.
Cheers.